Okay, in this section I'm going to go over some non-augmented matrix operations here. You can see some examples of non-augmented matrices here, their sizes and some names. Let's go ahead and just get right to it. Two matrices must be exactly the same size in order to add them or subtract them. So keep that in mind when adding or subtracting. It's really one of the simplest things you can do is to add two matrices. If you want to add two matrices like these two matrices, notice this one is a 3 by 2 and also the other matrix is a 3 by 2. So you can simply just add them together by adding each corresponding entry together. -2 plus -1 is -3. 3 plus 2 is 5. 0 plus -3 is -3. And 1 plus 2 is 3. And then 2 plus 5 is 7. And then -1 plus -2 is -3. This example here, you can't add them because they're different sizes. This is the first matrix is a 3 by 2. The second one is a 2 by 2. Subtraction basically works the same way. First of all, make sure they're the same size. This is a 2 by 2 matrix. This is a 2 by 2 matrix, so we can do the subtraction here. Just subtract like you normally would. 3 minus 5 is -2. -1 minus -3 would be -1 plus 3, which is 2. 2 minus 4 would be -2. 0 minus -1 would be 0 plus 1. You can go ahead and give this one a try, but it's pretty straightforward. Just subtract the corresponding entries. And again, you can't subtract these two because the first matrix is a 3 by 2, the second is a 2 by 2, and since subtraction is actually a form of addition, the same rule applies. They're different sizes, so the operation will be undefined. When you multiply a matrix by a real number, you're actually scaling the matrix. So sometimes this is called multiplying by a scalar. But in order to multiply a matrix by a real number, you just multiply each entry in the matrix by the number. So if I wanted to multiply this matrix by 5, I would multiply 5 times -1 and get -5. 5 times 1 is 5. 5 times 2 is 10. And 5 times 3 is 15. There's a guy who's not supposed to be there. So that would be the product that you get there. Here, just multiply everything in this matrix by -3 to get the result, and you can do that as a practice problem. Here I'm going to say 2 times this matrix minus 4 times this matrix. So what I want to do first is multiply everything in the first matrix by 2, so that would just give me -4, 6, 0, 2, 4, -2. And then I'm going to multiply everything in the second matrix by 4, so that would give me -4, 8, -12, 8, and then 20, -8. Now notice I kept the minus out here because I multiplied the inside by 4, not -4. So I'm still subtracting. So then just do your subtracting. -4 minus -4 is 4 plus 4, which is 0. 6 minus 8 is -2. 0 minus -12 is 0 plus 12, which is 12. And 2 minus 8 is -6. And 4 minus 20 is -16. And -2 minus -8 is -2 plus 8, which is 6. You can do these on the calculator by entering them in your calculator, but that's something you can search if you want to. Here are some practice problems. You can pause the video and practice on these if you want, and the answers are given. Another operation that you can do is multiplying two matrices together. In order to multiply two matrices together, you've got to make sure that you have in the first matrix, however many columns you have in the first matrix, you have to have the same number of rows in the second matrix. So if you look at this first matrix, you'll see it's a 1 by 3, and the second matrix is a 3 by 1. And since these inside numbers match, that tells me that I've got the same number of columns in the first matrix as I do rows in the second matrix. and that allows me to multiply. So to multiply a row by a column, a row matrix by a column matrix, it's pretty simple. You just take the first entry in the row and multiply it by the first entry in the column. So that would be 2 by 3. And then take the second entry in the row and multiply it by the second entry in the column. That'd be negative 3 times 5. And then take the third entry in the row and multiply it by the third entry in the column. And that would be negative 1 times negative 2. And then when you finish, add them all up. And 6 minus 15 is negative 9. And then plus 2 would give me negative 7. Now notice that this is basically a 1 by 1 matrix as for the result. And anytime you multiply a row by a column, the result is going to be just a 1 by 1 or a single entry. Okay, here's another one. You can do this one on your own. Give it a shot. Multiply this row by this column. Note that the number of columns in the first matrix is 4 and the number of rows in the second matrix is 4. So we are allowed to multiply that row by that column. Now, multiplying two matrices together, all it is just doing operations like this where you're multiplying rows by columns multiple times. So if I wanted to multiply this matrix here by this matrix beside it, then the first thing you want to look at is count the number of columns in the first matrix. You have 1, 2, 3 columns. So I have 3 columns. Okay, then I want to look at the rows in the second matrix. 1, 2, 3 rows. So I have 3 rows. Now as long as those two numbers match, then we can multiply them together. And they do. So how do we multiply them together? Well, don't let this diagram scare you. It's just like an instruction manual on how to multiply matrices. You take the first row from the first matrix and multiply it by each column in the second matrix. So if you look over here, you'll see I took the first row times the first column, the first row times the second column, the first row times the third column. And do that until you run out of columns, and then go to the next row and multiply it by each of the columns. So now I'll take the second row and multiply it by the first column, second row multiply it by the second column, and the second row times the third column. Now I've already shown you how to do this, but I'll just kind of walk through it with you with the top row. So when I multiply these two together, I take 1 times 2 plus negative 1 times negative 1, negative 2 times negative 1, and plus negative 1 times 1. And I get 2 plus 2 minus 1, which is 3. Remember, you get a single entry every time. And then multiply this row by this column, 1 times 0, plus negative 2 times 3, plus negative 1 times negative 3, and I get 0 minus 6 plus 3, which is negative 3. And then take this row times this column, I get 1 times negative 5, plus negative 2 times negative 2, plus negative 1 times 4, and that gives me minus 5 plus 4 minus 4, which is negative 5. And then if you multiply this row by each of the 3 columns the same way, you're going to get, for the second row, you're going to get negative 1, 3, and 2. So I'll let you multiply these out to see that when you multiply this product, you'll get negative 1. When you multiply this product, you'll get 3. And when you multiply this product, you'll get 2. And your final result should be a 2 by 3 matrix. And, here's the matrix that we get. Now, multiplying matrices is not commutative. Like if I took these same two matrices and tried to multiply them the other direction, then notice this would be a 3 by 3 matrix, and this would be a 2 by 3 matrix. Well, the first matrix has 3 columns, but the second matrix only has 2 rows. So if I tried to multiply this row by one of these columns, I would have somebody that doesn't match up. So when that happens, the result is undefined. So since these inside numbers don't match, then you can't multiply these two matrices together. Even if you can multiply them together in both directions, even if you can multiply them both directions, you're not necessarily going to get the same result. If I multiply these two matrices together one way, where I take A times b, then I'm going to get 1, 6, negative 1, negative 2. But then when I switch them around and multiply them the other way, b times a, I'm going to get a totally different result. So you can multiply these together using this diagram up here as your instruction manual, and you'll see that you get two different results when you multiply them one way and then multiply them the other way. There's a practice problem here that you can practice on if you want to practice multiplying, and the answer is given. Now let's talk about some applications. The first application gives you the labor hours for assembly and finishing for two items, item A and item B. The second matrix gives you the wages, the hourly wages for assembly in two states. So the plant in Arkansas pays $12 per hour for assembly, but the one in Texas pays $13. And for finishing department, Arkansas pays $7 an hour and Texas pays $8. Well, if you multiply W times L, you'll get some numbers. If you multiply on W times L, you'll get some numbers, but they don't really mean anything. So, but if you go L times W and you look at multiply them together, well, when you multiply, like let's just say you take this row and multiply it by this column. Okay, so it'd be 5 times 12 plus 1.5 times 7, which gives you 70.5. Well, what you're doing is you're taking item A, assembly hours, times the hourly assembly pay in Arkansas. So this is item A's assembly hours times the Arkansas pay wages. So that's $60. And then you're taking item A, finishing hours, times the hourly finishing pay in Arkansas. So that's like $10.50. So you're basically getting $60 plus $10.50 and $70.50. So that's giving you the total cost it takes the company to produce that product in Arkansas. And then if you multiply times the second column, it basically gives you the same thing, but for Texas. So 65 plus 12 would give you $77, and that's what it gives you the total cost for item A in Texas. And then if you do the bottom row, it'll give you the total cost for item B in Arkansas and the total cost for item B in Texas. So, good to know. All right, here's a couple more applications. Read this application here, and you can see that we've got two dealers. Dealer 1 sold this many of each type of car. Dealer 2 sold this many of each type of car. And this matrix tells you the revenue that each car brings in. So if you multiply these two matrices together, it will actually give you the revenue that dealer 1 brought into the company, and the second row will give you the revenue that dealer 2 brought into the company. Now this could be expanded to a larger problem here. Don't worry about trying to figure this out here, but you could expand this to more dealers and to where you have more dealers and more models of cars if you wanted to. Okay, so I'm going to leave you with letting you pause the video and look at these last couple of examples, and you can work through them yourself and then see how I solved them. So read these last two examples, and then that'll pretty much be it on this section. So just a couple more application problems there, so you can see that there are applications for matrix operations. One thing I would want to mention before I go is that if these applications make more sense if you think of them on a larger scale. So think of it as an application that has a lot more rows and a lot more columns than these examples do, and then you can see why a person might want to use matrices to solve some of these problems. Good day.